Hey folks, welcome to Advent of Code in F Sharp, and we're solving day 2 today. Yesterday, day 1, I was struggling a lot with the whole modular arithmetic, so that's why my video is not up yet. But I hope today will be better. We are working on day 2 gift shop, where we have ranges of IDs, and we have to find invalid IDs, which are concatenations of the same substring twice. So a repeat of an exact substring without anything in between. I already grabbed my input and the example, so we can get to work right away. So let's first parse our input or the example. We don't need a list, we can just use the input string. For today, so it's read all text. Why is it not? Okay. My IDE is still waking up, I guess. Okay, so we have our ranges individually, and then we have to parse the ranges. I had my AI assistant autocomplete enabled, but it was crap. Maybe I'm gonna enable it again. Sometimes it helps. So how do you enable completions? There we go. For parsing and stuff, that often saves me some time. And that's not the most exciting part about Advent of Code puzzles, so that's why I'm enabling it. Yeah, sure, that looks correct. Let's verify. 1122, 59, 115. They are big, so they are longs and 64s, and the last one seems correct as well. So, okay, this looks good. And let's wrap this in a function. Example, let's give it a type hint, so everything compiles, and let's rename this to input. So we can parse. What's next? Let's brute force, actually. So let's go over each and every range and just enumerate all the IDs we find in there and check for repeat substrings. So I'm going to work on a single one for now. The first range. Start. What were the official terms? First and last. And let's enumerate. Let's just do a list comprehension from, or I don't know what the term is. What is the term for this? The thing where you enumerate or generate a list based on the elements and like a step size. I don't know what you call this. What is this operator? If you do F sharp, you know what this operator is called. Let me know in the comments. Okay, but now we're enumerating, and let's filter out everything we want, right? So let's map it back to stringland. Yeah, that's easier to do what we're supposed to be doing. So let's map. I'm gonna stay in the list world. Can I just do a string? I can. So this gives us strings again, and now we need to split every string into 2 halves, and if they are equal, we have a valid or an invalid ID. I'm just gonna smoosh. No, let's keep it in a separate step in the process, separate pipeline. Let's write an inline function quickly. What are we going to do? Substring it? Split? Can you split by length? Maybe define the function argument. There we go. Does split take an index? No. Substring does. Yeah, let's do substring, right? For substring, we need to do a bit of testing. What does this mean? starting from character 1 to the finish. And so test is 4 letters long if we want to split it in 2. Yeah. How do we get the first part? 0, 2 is 2, or is it inclusive or not? Ah, okay. So we need to calculate the 2, which is half the string's length. Right. This should be what we're looking for. We can just use string everywhere, and this snippet should split our string into 2, right? No. Oh yeah, divided by 2. So it's a length divided by 2, and that should go in here. And that should be 2. Yeah. So if we put that in a tuple, we now have a function that can split a string into 2. Let split. There we go. There we go, there we go. That should all work. And this is our split function. Do we need to test this with strings that are not an even amount of characters? Nah, we could short circuit. We could short circuit a whole lot. Yeah, let's do that. So let's filter out. This is premature optimization. And by saying that, let's not do it. Let's do that if things are really slow. And we could filter out all the uneven length strings and not even look at them. But okay, so let's map our split on it. So now we have for a range all pairs. And we need to count the number of splits where the 2 parts are identical. Let's call this AB. My creativity is at a low at 6 o'clock in the morning. So what are we doing? Set intersect is empty. No, let's do just A equals B. These autocompletes. Yeah, okay, so this is what we need. And we just need to count them. So I think this is correct. Oh, we don't need to count them, we need to add them, right? Adding up all int IDs. So instead of just splitting, let's do let's keep the original ID in there. So that's ID and the split pair. There we go. So then we have the original ID in there, and we can easily keep it. Maybe we should have done this before we mapped to string. Yeah. So I'm just expanding my pipeline, adding an extra bit of data in there. There we go. There we go. So we expand the pipeline, so we have the original ID and the subsplit, and we filtered, and we just take the first elements again. So now we have all the invalid IDs, and if we... yeah, that's okay. So let's call this invalid IDs in range, which is first last. There we go. So this function should calculate or return all invalid IDs. And let's test that out on ranges first element. Yeah, that works. So there we go. These are some utility functions. This can go. And now we have to do this for every range. So we need to map or collect. Collect is mapping, but also flattening all the resulting lists into a single list. Array, so let's do an array map Why is this not working? Ranges is an array of tuples of longs. This takes a tuple of a long. Okay, and it returns a list. That's the problem. Okay, so this should work. And we just need to count it. No, we need to sum it. 1, 2, 2, 5, 5, 4. 1, 2, 2, 5, 5, 4. That looks correct. I have not written any tests. We have been validating by using the REPL, but let's put at least one thing in a test. So we have some regression once we start mucking about if it's not correct. So I'm going to introduce a solve function. I'm ignoring all the completions because they would probably not help me. And let's use the range. There we go. Yeah, this solve function looks correct. It returns a long. So if we solve the example, we should see something we like, which is test pass. Yes. So let's run our solver on the input for part 1. Input string was not in the correct format. Interesting. The string is empty. Sorry. Oh, I'm looking at the wrong file. That is on me. That's because I incorrectly copy-pasted something. Let me fix this for today and for tomorrow, so I never have to look at this again. This is the part I'm interested in. This is the part I'm interested in. So if you're unfamiliar with source directory, it's I don't know what it is, some kind of directive, but if you evaluate that, it points to the current directory, which is useful in a lot of F# scripting. Yeah, so now we should be able to solve for our input. It took a while, so it's not the fastest approach, this brute forcing, but I have high hopes that this is correct. Yes, warranted. Cool. Is my frame rate laggy? Is Rider hogging up all resources again? Let me do a quick check before proceeding on to part 2. No, nothing seems to be happening. So let's continue. Before we start reading, lest I forget, let's copy the entire script into a part 2 file. So we can start hacking away at part 2. The clerk quickly discovers that there are still invalid IDs in the ranges. Maybe the young elf was doing other silly patterns. An ID is invalid if it is made only of some sequence of digits repeated at least twice. Oh no. So our splitting, that was an easy one, but now if something is repeated even more than once, or more than twice, it's also invalid. 111 is an example, 1010 is an example, 999 is a better example. Is there something with 3 repeats? This is a good one. So this. Okay, so we have to make our split a bit more exhaustive, where we don't just split once in the middle, but split like at every possible. We could make the split smartish. What happens if we already filter out the our idea of filtering out every number that has like an odd number of digits? Will that speed up our process? Let's see if that speeds up our solve a bit. So I'm going to do some low tier benchmarking. This pound time thing shows you an idea of how many milliseconds it takes to evaluate an F# statement. So this takes like half a second. What happens if we filter out all strings that are uneven. This benchmark is not representative, of course. We only run it just the once, and I'm running Spotify, OBS, lots of software on my machine. So, but anyway, let's continue. It's funny that it already proposes, this autocomplete is already proposing a filter on even numbers. That's interesting. Where did it get that? Okay, but let's see whether or not this is functionally correct. It is. Does it solve faster? Maybe 20% gain? No, maybe not. Okay, but let's keep it in there. It's still the same answer. Yeah, so that's not introducing any bugs. Okay, so our split only splits just the once. So these two lines need to change. Instead of just having like one split, we need to evaluate whether or not there's any repeat or any number of substrings. Okay, let's play around with some examples to get a feel for the problem. I like this example. Let's put that benchmark thing out. Let's disable it for now. What's a good way to figure out that this is an invalid ID? We could just brute force it, like take chunks of 1, chunks of 2, chunks of 3 up until the entire string. Or we could take munch up the string until we hit like a digit we recognize. Is that already too much for my 6 o'clock sleep-deprived brain to implement? Yeah, let's maybe do it naively first, and we could figure out some cool heuristics if we need to. So what changes our split? Yeah, what happens if we make our split a bit smarter, where we just this dividing by 2 thing? If we just provide the 2 as an input argument, instead of like 2 elements, we do this recursively. We nibble up. If all our strings are even, is that actually necessary? If we have like a repeat of 3 ones, the string is not even. So actually we introduced a bug for part 2. This filtering on even strings, that has to go. For example, the 111, that's not an even string, but it is an invalid ID, if I remember correctly. Yeah, so yeah, that was a very bad move. Okay, so I'm getting an idea of the problem space here, or the solution space. We're gonna make a smarter split, and that we can use incrementally, and that splits. Oh, actually, there's a nice utility method we can use. Chunk by size. If you chunk a list or a sequence, strings are not lists, but sequences. It's the IEnumerable of C#. If you chunk that by size 3, I think this is exactly what we need. Yeah, I think this will work. So if we implement our split in terms of chunk by size, whoa, we can feed it in incrementally larger lengths, chunk sizes. And if all those, that is correct, right? If all those sublists are identical, yeah. So let's call this chunks. We chunk by size, whatever. So let's have a size argument. And if we chunk by the size, and then if they are all identical, we have an invalid ID. So let's grab this. Are we staying in the long world? No, we can just keep it in the string world. That doesn't matter too much. We have our chunks, and if all those chunks are identical, we have an invalid ID. So how do we easily figure out whether all chunks are identical? We just put everything, we dedupe everything. And if the length is 1, we're there, right? So if we have 1, if the length of a deduped list is 1. Oh, sorry. Oh yeah. Chunks, we actually have to make an invalid ID for this. And it's true, yeah. So I think this is a good first building block for our solution. So it takes an ID, and we chunk it, and chunks. It also takes a size, a sequence, and an integer returns a bool. And if we call this recursively on size and return success at the first hit, we're there. So I'm gonna wrap this into a bigger invalid function. And this is a helper function. What am I doing? Let me roll back a bit. So we need to loop over size, or start with a small size, or a big size, doesn't really matter. And we need to loop over that, right? Yeah. Okay, so let's write a completely new function. My creative brain isn't blocking on the name, so I'm just going to call it a very bad name just for now. And it just takes an ID. And let's also have it get a size. Yeah. If the size equals 0, so we're going to go from half of the string to this. If we have found nothing, then it's not an invalid ID. Maybe we should call it valid instead. Nah, too difficult. Otherwise, we have a non-zero size, and we can do invalid ID by size. If the ID is invalid in that size, then we have an invalid ID, and otherwise we're not sure, and we need to recurse. Suggestion was actually correct. Yeah, so this is recursively doing this thing, starting with a size and shrinking it. So in order to call this, hell yeah, I love my naming today. And then we take the half-Cs and start from there. And it's a string, we have half, so there we go. So this should work, apart from the horrible, horrible naming. So let's see whether or not it works. It's a repeater. Why am I starting with half? Which is 1, 2, 3, 4. Ooh, will we have off by 1 things because we have sometimes uneven strings? Am I making this too big of a deal? I think I'm making this too big of a deal. So this should return true. Yes, and if we put something else in it, it should return false. Yeah. I am feeling good about this. I'm gonna grab these two, hide them away as inner functions. So we can hide all that nastiness away. Oh, this is horrible. I'm sorry for this. Okay, so this should work. And now all the nasty bits are hidden away. They're still there, they're still nasty, but at least I can click them and they disappear. So cool. We can continue. I'm gonna put in all those examples because I don't trust myself. Let's just grab these examples. Is that something we can have GenAI generate for us? Yes. So I'm not gonna waste my time transforming that to like my sonnets. Oh, you know what? I'm gonna use voice completion. I'm used to doing that. Let's write some unit tests for the invalid function based on this data. That should probably give us something workable. $11, $22, $99, $111, $999. I don't know where it's getting all those others. Those are like edge cases. Yeah, those are like edge cases. It's trying to run the scripture. Actually built an MCP server where my GitHub Copilot or whatever AI assistant I use can like interact with my active REPL. But I haven't enabled it for Advent of Code because I didn't think I was going to do a lot of AI assistance. I don't like using it for solving the problems, but for stuff like this, generating a lot of tests based on the problem description, I think it's okay. That's the boring, tedious part I want to get rid of. So, okay. I think our invalid thing is working. Let me get rid of our tests. Okay, so our invalid thing might be working. That's at least our working assumption. So let's plug that into our solve. And for that, we need to be here. I'm moving some stuff around here so we can use our invalid function in this invalid IDs. Yeah, and this has to be list filter list filter where the string IDs are invalid, and then just like map them, and this will give us a list of all invalid IDs. So let's quickly test that. Invalid IDs. Do we have one with more than one? Yeah, this range. So this should give us problems. Okay, 999, 1010, that looks correct. So let's put that in our tests as well. And this is the result we're looking for. This is the result we're looking for. Yeah, there we go. The example should give us a sum of invalid IDs still. Yeah, I think that's still correct. We don't need to name that. Okay, so let's solve the example and see how far we get. 417265. 417265. Correctamundo. But now, will this scale? I have my doubts. But if this takes a couple of seconds, I will not be working on performance. So let's put our timing on and let's solve this. Oh no. Oh no. Oh, actually, that wasn't too bad. Only 10 seconds. In the realm of brute forcing, I am perfectly fine by accepting horrible performance. And we actually got our second star. This was fun. I am very interested if you've solved day 2, whether or not you went down a more performant route, a non-brute force route. So if you have a different solution, please let me know in the comments. And I hope to see you again for more F# fun tomorrow. Bye-bye.